This is the prep packet video for Unit 4, Chapter 9.3. We're looking at objective number 1, which is about multiplying square roots. Before we get started, I want to sort of give you a little overview. The nice thing about multiplying square roots is it's pretty simple. All you really have to look at is you're going to multiply the square root of 4 times the square root of 9. And what's nice is you get to combine them both underneath the radical sign. So I started with the square root of 4, and then I had the square root of 9, and then they combine all under one roof, 4 times 9. And then once you get to this point, do the multiplication, and if you look at this, it's quite nice because it's a perfect square. So the answer to that in the end is 6. So the official formal way of putting it is let A and B be non-negative real numbers, and then you can just multiply them and put them under the radical. In case you need a little vocabulary refresher, the entire thing is the radical. The little division-y thing is the radical sign. The number inside is called the radicand. And this is a word that we're going to use a lot in this unit, and that's the index. And that you've seen before is the little tiny number that tells you how many factors you're actually looking for. Here's a little vocabulary alert. The singular form of index, you know, but you might not know that if you have more than one index, they're called indices. And you can only do the multiplication routine if and only if the indices are the same. So you can multiply the cube root of 7 times the cube root of 9 and get the cube root of 63, but you cannot do the square root of 6 times the fifth root of 11. Because the indices are different, it's a no. You can't do it. It's no, no, no. Okay, and just to let you know though, there is a way we can deal with them if they have different indices, but that's for later. So that's sort of an overview. Let's take a look at a couple of problems. This is pretty fast and simple. Here, they're the same index. They're both, I'm taking the square root of both of those numbers. So I can do this, 7 times 3, and that will be the square root of 21. Remember, because both of these numbers are prime, I won't be able to do anything with that in terms of taking out a root. Over here, it's the same idea. The square root of 5 times the square root of g is the same as saying the square root of 5g. And the reason this works is because of the product rule. Okay, go ahead and take a look in your book. I would like you to try the U-tries, that's the little ones in the orange in your book, on page 535. Make sure you include that work with your prep packet, because I want to give you a chance to have a little more practice with this than just the two problems. And that's it for Objective 1. Thanks.